Today, I'll walk through a plan to build a machine learning model to forecast demand for new applications or renewal applications for public service programs like SNAP and Medicaid, which will help supervisors and program administrators plan workloads and improve service delivery. The timing of processing new applications or renewals is critical for citizens to receive the benefits they need when they need them, and the states to remain compliant with federal regulations is also imperative. Thousands of new applications or renewals are processed each month, and those numbers can climb into the tens of thousands when there is a national emergency like COVID or significant policy change issued by federal agencies like CMS or FNS. These spikes in demand make it challenging for supervisors to determine staffing levels and efficiently allocate resources to meet day-to-day demands. Today, scheduling is reactive and based on intuition. Program directors and supervisors are looking for a viable solution, and a predictive machine learning model forecasting caseload demands could help them manage workload and make staffing plans. The goal of this solution is to support decision making for supervisors by predicting demand of new applications or renewals for a given day or through the week. Insights and spikes in demand will help them manage intake for programs like SNAP and healthcare benefits. Supervisors are unable to anticipate these workloads today. Demand is sporadic, it's spiky. A lot of it is driven by calendar events or policy changes or some macro impacts or changes. Without a demand forecast, staffing becomes a reactive activity. Meeting and compliance for requirements can be a challenge, but more importantly, providing a seamless customer experience is difficult. Success means measurable improvements like fewer backlogs, faster processing times for applications or renewals, and more importantly, meeting compliance requirements for how long it takes to get a application or renewal completed and benefits provided to citizens. The solution would visualize forecasting trends, outcome metrics, and model evaluation metrics through the development of a dashboard, which will be made available through an application like Tableau. It will also be able to help supervisors and program administrators gauge how well the model performs. The following are some of the relevant factors or features we'll need to feed into the model, including historical caseload data and rolling averages, as well as some calendar-driven events in terms of the spikes of applications and renewals. This historical perspective would be helpful. Program details, as in terms of what type of program we're talking about, as well as external drivers, as I mentioned before, these could be macroeconomic events or policy changes. The plan is to validate through the solution through iterative experiments. We would start with a baseline, then iteratively add random forests to account for nonlinearities between upstream events and volume of applicants, and gradient boosted trees to help optimize mean square error. For user validation, we will engage supervisors to share comparisons of 4 to 6 weeks of pilot forecasts to actuals and solicit their qualitative feedback on the usefulness of the predictions for staffing decisions. Of particular interest is understanding which upstream signals, whether it be policy changes, outreach campaigns, or macro events, or other things that translate into actionable forecasts that program administrators can use for planning purposes. In terms of how the system will be architected, the system will run in the cloud for scalability. We will retrain models offline at a cadence of weekly or monthly and generate forecasts for supervisors through a batch process that will be delivered via metrics to a Tableau dashboard. Potential risks that we might encounter in production include data drift due to external conditions shifting, concept drift as well for long-term changes and potential overfitting. Retraining, monitoring, and aligning data will be used to help mitigate some of these risks. In summary, machine learning can help supervisors anticipate workload, allocate staff more effectively, and improve service delivery. In terms of next steps, we will be looking to pilot this solution and scale it across, starting with one program and then scaling it across all other programs. And that concludes my presentation for today.